All right, hi, you probability luminaries. This is my response to Emma's question that she sent last night. Apparently, Emma and Elise and Katie were working on some stuff. I'm going to go ahead and respond to this right here. Just easiest to do. So I'm looking at 46 first here. I think this is the picture I have up. So it looks like we have a jury of 12, and we have that we need 9 votes to convict a defendant of whatever it is they're accused of doing. And I'm sitting here and I'm looking at your computation. Okay, so we have various probabilities that are given to us. For instance, like 80% of jurors will vote to convict given that the individual is guilty. Okay? And that means that a juror will vote to acquit 20% of the time given that the individual is guilty. Okay? That's the way you should render those that information right there. It says, suppose also that the probability that a juror votes a guilty person innocent is 0.2. All right, so that means you know that the person, there's that we have some kind of level of omniscience here. We know that this person is guilty, and we're just observing how jurors tend to vote about that guilty person. Okay, and it says that they will vote wrong 20% of the time if the person is guilty. On the other hand, if they are innocent, they will vote to convict 10% of the time. Now, that's why I have I guess I don't understand this computation right here. You say the probability that they are correct is the probability that they are convicted and guilty. And there you mean vote correct, and that they vote to convict and the person is guilty. That's what you mean, I think. Plus the probability that you vote not to convict, right? You vote to acquit, and the person is actually innocent. Well, it seems to me that you should be multiplying 0.65 times 0.8. Okay, because what is the probability that you convict and the person is guilty? Okay, that you vote to convict and the person is guilty. So the probability that you vote to convict and the person is actually guilty, well, that's equal to the probability that they are guilty times the probability that you vote to convict given that they are guilty. Okay, and that's information that was given to you. The probability that they are guilty, what's that? That's 0.65. That's 0.65 times the probability that a juror, we're talking about an individual juror here, right? The probability that an individual juror will vote to actually convict given that they are guilty. All right, so what is that? They will vote to convict given that they are guilty. Isn't that 80% of the time? Yeah, because it says, suppose also that the probability that a juror votes a guilty person, that is someone who is actually guilty, that they will vote them to be innocent is 0.2. So that means that the probability that the juror will vote a guilty person, to be guilty, that will happen 80% of the time. Okay? that will happen 80% of the time. So that should be 0.65 times 0.8, I think. Yeah? And then it would be plus, right, 0.65 times 0.8. And then I think that, okay, you also want the probability that they will vote to acquit and that they are innocent. Okay? That's like your second summand right there. Well, what is that? That is equal to the probability that they are innocent times the probability that you will vote to acquit given that they are innocent. Okay? So what's the probability that they are innocent? Well, that's 35%, 0.35. And then what? And then you have to multiply by the probability that they vote to acquit, given that they're innocent. Well, I think that's right here in the problem, right? It says, whereas the probability that a juror votes an innocent person guilty is 0.1. Juror votes an innocent person guilty, says you know the person is innocent, and they vote guilty, that's 10%. So they will, okay, so an innocent person will be voted not guilty 90% of the time. So you would multiply 0.35 times 0.9. So I feel like you have those two numbers switched. 0.9 and 0.8 should be switched around. Okay? Yeah. Okay, so that would be the probability that a given juror votes correctly. All right? Votes correctly. So that would be the probability that a given juror votes correctly. So the probability of a correct individual vote would be equal to 0.65 times 0.8 plus 0.35 times 0.9. Yeah, which is 0.835, which is a little bit different from what you actually have there. Okay. All right. So let's see here. I'm going to pause this right here because I don't want this to get too super long, but that's at least the first the first part of that one. So there is a little bit of correction that needs to happen there. But I'm going to come back in here and try to discern what's going on with the second half of this. All right? So I'll be back.